three blocks are connected together and are hanging. Each block has a weight of 15 newtons. What is the net force of the system? So the first thing we have to do is identify any relevant concepts, variables, and figure out what our target variables are going to be for this problem. Here we're going to be looking for the net force. Now we were given the weight, which is 15 newtons, and this is for each of the blocks. So this will be for the weight of block A, the weight of block B, and the weight of block C. Now that we identified some concepts that we're going to be using, let's go ahead and set up the problem. For the problem, we have to figure out what the net force is going to be. So the net force is going to be, of course, the weight of the three blocks. So we got weight A plus weight B plus weight C. But that's not actually the entire problem. If we were to go ahead and draw the diagram, it was asking us for the complete system. So what we can do is turn block A, B, C into one actual object, like so, and it has one complete weight, pulling it down. But it also had a string, or a rope, pulling it up. So as you can see, there are really two forces, main forces, that are acting on the system when you resolve it into one complete object. And when we do that, we also note that the system isn't moving. So if the system isn't moving, we are also given by Newton's second law that the sum of the forces equals the mass times the acceleration. And since it's not moving, that means acceleration is actually 0. So let's go ahead and execute that. If we were to evaluate it, F is equal to the mass, which we haven't found out just yet, but if we wanted to find out what the mass of the entire system was, we could do the weight is equal to the mass times the gravity, and then solve for m. M is equal to the weight divided by g. So we can go ahead and plug this in. Here we are using a because this is the acceleration of the complete system. So that would equal w divided by g times a. But we just noted that the system isn't moving. So we have w divided by g times 0, which equals 0. So the net force on the system is 0. Now let's go ahead and evaluate that. We have a system here. It has a weight pulling it down, and it also has a tension pulling it up. I'll signify that with a T and a W, like so. Now, yes, of course, there are many forces that are acting on the system, but the idea is the net force, which it was asking us for, is actually 0. So this checks out according to Newton's first law, which is a body acted on by no net force moves with constant velocity, which can be the same as 0 and 0 acceleration.